Hello student, I am Dr. S. Natarajan, Department of Mechanical Engineering from VMKV Engineering College. Today we are going to discuss about the pump classifications and gear pumps. Okay. You know, the pump is the one of the most important device in hydraulic systems. The pump is not only used for hydraulic system, it is used in many places. In our day to day life, we are using pumps for lifting water from well to overhead tanks. In our day to day life, we are using pumps for RO purification systems. We are using pumps for fuel stations for filling the tanks. We use some different pumps for cleaning the cars and pressurizing the liquid. Some many different types of pumps we are using in our day to day life. So, based on the application and engineering involved, the pumps are classified in different types. We will discuss in today class the classification of pumps and the construction and working of gear pumps. A pump is the heart of a hydraulic system. So, we know the function of our heart. Heart is from birth to death continuously pumping the blood to our body. Like that, in a hydraulic pump the or pressurize the fluid to actuate different actuator present in the systems. Now, we are going to discuss about the pump classification. So, in this view, you are seeing various classification of pumps. Pumps in generally classified in two types. One is the positive displacement pump, in technically otherwise called hydrostatic pump. In other category, non-positive displacement pump or hydrodynamic pump. First, we discuss about this hydrodynamic pumps. The hydrodynamic pump, it having lesser classification here. It is coming under two categories. One is the centrifugal pump and another one is the axial pump. This the centrifugal pump producing huge quantity of flow, but it is not able to pressurize much. In this, the centrifugal pumps widely used in irrigation application in the agriculture field and thermal power station for pumping the waters to boilers and many more application. In this pump, hydrodynamic pump, it is non-positive, because why it is called non-positive displacement pump means this pump is not deliver constant quantity of fluid for each and every revolution. So, there is some slip is there between this pump is rotating very slow speed, it is not able to deliver the fluid. So, the slip is there. Well, the speed of the pump is increased, it producing the output. It is generally used in our day to day application, bore well, open wells and other thing. It is also in, coming in this category, based on the fluid flow, it is the fluid flow parallel to this pump axis, it is called axial pump. It is the classification coming under non-positive displacement category. But in our application, we are not using these pumps. For understanding purpose, we are discussing about this pump. So, in our hydraulic application, we use only the positive displacement pumps. This positive displacement pump having many categories. this pump is broadly classified in further to the rotary pumps and reciprocating pumps. The rotary pumps means the pump axis make rotational motions. Reciprocating pump means the pump is actuated in the to and fro motion, reciprocating motions. In this rotary pump category, we are having many classification: gear pump, lobe pump, van pump, screw pump, piston pump, peristaltic pump, and flexible impeller pump. These are the some categories of these rotary pumps. In reciprocating pumps, two pumps, the piston pump and diaphragm pumps. These piston pumps are pumps you know very well. They are used in service stations for pressurizing, moderate pressurizing the fluid and cleaning the vehicles. The diaphragm pump, these are the pump used. This pump also used for some light, some medium pressure application. This diaphragm pump mainly used for fuel lifting purpose. So, you take our buses and trucks, you know the position of fuel tank. The fuel tank, level of the fuel tank lower than the level of engine. So, we need some form of power source required to transfer the fluid from fuel tank to vehicle. So, in this application mostly we used for pumping the fuel, we use diaphragm pump. So, this pump also we are not used in this diaphragm pump for hydraulic application. The piston pump we used widely. The piston pump further it is classified in two types, bent axis piston pump, Schwarz plate piston pump. These pumps are axial piston pump category. In another category is there radial piston pump. The radial piston pumps used the pistons in radial direction to the rotational axis, because that pump is called radial piston pump. Okay, we again come to rotary piston pump, rotary pumps. This rotary pump, the gear pump is the plays main role in hydraulic application. The gear pump having many classification in it: the external gear pump, internal gear pump, lobe pump, gerotor pump, screw pump, etc. It having many category. All the pumps till now used in our hydraulic application. And then van pump is there, and piston pump, lobe pump, screw pump, peristaltic and flexible impeller pump. These pumps are some recent developments used for some medium pressure applications. So, based on the selection of the pump, based on the application, pressure required, and various factors are involved in the selection of pump. Now, we are going to discuss about the construction and working principle of external gear pump. The external gear pump, the image shows the sectional view of a external gear pump. This pump having two external gears. One is the driver gear, another is the driven gear. The driver gear is coupled with a prime mover called, prime mover may be a electric motor or diesel engine. Any one of the prime mover we are using to actuate this pump. So, because of this external gears, this pump is named as external gear pump. These two gears are missed each other, and also the gear tooth always made contact with the pump casing This gear pump, the gear pump casing and gears are manufactured in the precision of fluid tight manner. This pump having a casing, and one gear is driven by a motor, another gear is driven by the driver gear. So, this construction is very simple. Now we are discussing the working of this pump. In this slide, how the fluid is taken by this pump. You see this image, step by step explanation is given through this image. The pump receives the fluid, and the further rotation of this gear, both the gears are rotating in opposite manner. Further rotation of the gear, gap between the gear tooth and pump casing, and carries certain quantity of fluid. Both the gears and the gap between the gear tooths and pump casing carries certain quantity of fluid. This fluid is continuously moved, and at the position of outlet, both the gear tooths delivering the fluid. So now the flow will happen. The flow happening. If we not connected any load in the outlet, just flow. The pump not consumed much energy. Once we connected with load, we are at that time only the pressure built in the outlet and the fluid is pressurized. This pressurized fluid is used to do some useful work. You see this animation, that working of this pump, that fluid in here, and due to this continuous rotation, the fluid is delivered here and the fluid is moving to out. As I said earlier, we are not connected any load, the pump freely rotate. It's consume very less amount of energy. When we connected to the load, the pump produce the pressure. So in this pressure is we are using to do some useful work. Before going to the end, we discussed that theoretical discharge of this pump. The theoretical discharge is Qt equal to 5 by 4 into dO minus di whole square. It is the volumetric displacement of the pump multiplied with speed of the pump, it is called N RPM, into B, it is the width of the gear. A gear is there, you assume this is a gear blank. The gear blank having so it is called B, breadth of the gear. So we will get the theoretical discharge of this pump, meter cube per minute. Okay. So the advantage and disadvantage of this pump having high speed, used for high pressure application, no overhang bearings. Here some other designs, some other pumps having overhang bearings. So due to this design, the bearings frequently we want to replace, but in this pump that problem is reduced, and this pump relatively quiet operation. This pump works very quietly, and this pump designed for accommodate wide variety of materials. So these are the some advantage. Not only this, most of the hydraulic application in JCB, road rollers, hydraulic road rollers, hydraulic lifts, and many more applications, more than 50% of hydraulic application this pump only used. Rest of the 50% application is shared by other pumps. Okay. So this pump not able to handle solids. It handles semi-solids, but not able to handle solids, and it having fixed anti-clearance. So, that is all. This pump we are not able to adjust the quantity of fluid. It is constant quantity of fluid only available for each and every revolution. The same quantity of fluid flow only available. We are not able to adjust the quantity of flow. If you want to adjust the quantity of flow, you see in this equation the volume is constant. Here volume is constant, we are not able to adjust, and B, breadth of the gear, it is also coming in design, we are not able to adjust. If you want to varying the quantity of discharge, we need just change the N, just changing the RPM only we are able to adjust the discharge of this pump. So, it is the fixed displacement pump. Okay. So, that is the drawback. In this pump having huge applications, it handle various fuels, oils and lube oils, etc. It handled. Even many of our automobile IC engines having lubrication circuit. That lubrication is pumped by this kind of pumps, mostly this pump, head gear pumps, and chemical additives, polymer and chemical mixing and blending application. We are using double pump. We rotate the required ratio, rotate this pump on required ratio, we will make chemical blending using this pump. It is the because this pump each and every revolution it producing correct quantity of fluid. So, that is why for making some perfect combination, we use this pump with suitable revolutions. Blending, it is the important application of this pump. And then industrial and mobile hydraulic application. What is mobile hydraulic application? Few years back, some vehicles are designed only with the hydraulic transmission. So, in automobile, the transmission system is the complex one. What is transmission system? Transmission system means how the engine power is transferred to engine to road wheel. That is the what are the devices involved, that devices coming under transmission system, but it is the complex. You take a train engine, the train engine there is no solution for transmit the engine energy to traction wheels till now. There is no mechanical solution. So, that is why the engineers going for electrical technology. In you take train diesel engine runs by diesel, you know, like our cars and buses, but the power transmission is purely electrical. That is the beauty. The engine train engine, the engine located in the platform of the train engine, that engine is coupled with huge generator, the traction wheel having small individual motors. For example, the engine generator is 3000 horsepower, the road wheels is having 6 wheels for most of the diesel train engines, each wheel having 500 horsepower. So, that 300 horsepower is shared by this 6 traction motors, each designed for 500. So, the energy transferred through the cable only, no other mechanical transmission technique till now available. The steam engine, they are used some peculiar transmission system, but after come to the use of diesel engines, that there is no mechanical transmissions are available, only electrical form of transmission only happened in the diesel train engine. So, that is why in mobile hydraulics you take some small cranes, you take a huge earth moving vehicles, backhoe vehicles, JCB like vehicles, that vehicles also having road wheels. That wheels is not having a conventional transmission system like clutch and gearbox, all other things. That is wheels coupled with one hydraulic motor. That hydraulic motor drive the road wheels. So, it is the one of the application, and not only this pump used as the motor. This pump just here you are supplying the fluid. That what is the definition of this pump? Pump is a mechanical device used to convert the mechanical energy into pressurized hydraulic energy. So, it is the definition for pump. The mechanical energy is converted pressurized hydraulic energy. The same construction, the same pump, you are supplying the pressurized hydraulic fluid to this pump, the pump shaft producing the mechanical output. So, this pump works as a pump as well as actuator. Also, most of the pumps bidirectional flow, both the direction this pumps able to deliver the fluid. Now, there is no fixed inlet, fixed outlet. If you based on the rotation of this pump produce the delivery. Now, also this pump used for very low volume transfer application, very low volume transfer application. This pump acids and caustics, some other material also this pump able to handle. We are going to discuss about the internal gear pump. The internal gear pump, that working is similar to external gear pump, but it having entirely different construction. Okay. This pump is you see that image, this pump having the, it is a pump casing, it is the pump casing. See, it is the casing of this pump. Okay. Inside this casing, one internal gear is mounted. You see, it is the internal gear. This gear having tooth inside on it. So, that is why this pump is called internal gear pump. You see this gear profile, it having internally toothed gears, inside toothed gears. So, you see here, you see the difference. It is the external gear. Okay. It is the internal gear. Okay. It is the you see this outer gear. This gear tooth is formed internal gears. Internal form, that is why this pump is named internal gear pump. That previous is the external gear, means that two gears are having external tooth, but in this pump only one internal gear and one external gear, that is inner gear shown here. This you see this tooth, it is externally toothed. Okay, external tooth, but you see this having internally toothed. It's a internally two gears are used. You see that this internally used, that is external gear. This gear is having key. It is connected with a prime mover, engine or electric motor. This gear only driver gear. Okay. When this gear rotates, this internal gear mixed with this gear automatically rotated by this gear in this external gear. Okay. And here you see one element, it is called crescent seal. this crescent seal, it is the crescent seal, it is the crescent seal, it separates the two gears, internal gear and this internal gear and this external gear is separated here. So, now you understand the center of the external gear is located here, the center of internal gear is located somewhere outer. So, both the gears is not located in concentric manner, these two gears are located in somewhat eccentric manner, that is based on the thickness of this crescent seal. Okay. So, the crescent seal separate this internal and external gear. The inlet portion is arranged here, the inlet portion is provided here, the fluid is allowed to move into this pump and outlet is provided here, move out, right. So, this is the construction of this pump, and the working of this pump, these pumps, what are the pumps we discussed, internal and external, both the pumps, we want to maintain the fluid level near to its axis. This pump never create vacuum, never suck the fluid. We want to maintain the fluid level at least equal to the axis of this pump, both the pump. Then only it take the fluid. This pump never create suction. So, we want to provide the fluid at the level of the shaft of this pump, that is mandatory for operating these pumps. And then the fluid is allowed to here and the gap between the tooth. Now, you see when it rotate in anti-clockwise direction, considering the arrangement of this pump, the rotation of the gear is very important. This diagram, the direction of rotation is missed, but when you draw the diagram, the rotation must, the direction of rotation is must. So, in this the fluid is entering here, you see here the pump tooths are very close missed. When it move further, the volume getting increased, the gap between these two tooths are gradually increasing. This increase of volume receive the fluid from inlet, increase of the volume receive the fluid from inlet. This fluid is taken by this both the gear tooths. After this position, after the crescent seal, the tooths of two gears are separated. The role of crescent seal just to separate the internal and the external gear tooths. Now, you see this gap between this tooth carries certain quantity of fluid. This fluid is for the further rotation, it is transferred. All the tooths in this point deliver the fluid, delivering the fluid. So, in this continuous rotation, continuously fluid is delivered in this point, there is no space for further movement of the fluid. Almost in this location both the gears are getting meshed together. So, that is why the fluids are squeezed to force outside. So, it will produce the flow on the outlet direction. So, as I said earlier, we are not connected to any load on the outlet side, just flow only is there. When we connected to the load, the pressure built in the pump, that pressure is used to do the useful work. Okay. See the animation of working of this internal gear pump, it is the internal external toothed pump, it is the internal toothed gear, it is the crescent seal, it is the crescent seal. When this gear is rotated, the outer gear automatically rotate inside the pump casing. Here it receives the fluid, in this position it delivering the fluid. It is the construction and working of a internal gear pump. The discharge calculation very similar to the previous one. We discussed the advantage. Only two moving parts, and it is the advantage of this pump. Maintenance is easy, excellent for high viscosity fluids. This pump used for handle tar like liquids, and constant and even discharge in this pump is smooth discharge. The discharge is not having any pulsation. It is the advantages of this pump. This pump operate well in either direction. It is also bidirectional. Pump the fluid in forward direction or reverse direction. Easy to maintenance and flexible design. Disadvantage of this pump is not used for high speed application, but external gear pump used for high speed application. That medium pressure only, pressure limitation is that this pump, because I told earlier that external gear pump not having any overhanging gear arrangement, but in this pump overhanging gear arrangement is there, that is inside gear is overhanged. That is why it is very high pressure is not possible in this pump. One bearing runs on the product pump. Only one set of bearing withstand the whole load. The overhang load shaft bearing, this bending moment happens on the pump shaft. The frequent maintenance is required. This expensive to manufacture and maintain this type of pump. But till now, some applications these pumps are needed for lubricating the engine, IC engines, like that applications this pump used. The all variety of fuel oils and lube oils it will handle, and resins, polymers. These are used in present day composite manufacturing. We need this kind of resins and polymers we need to handle. It is handled by using this type of pump. Then alcohols, solvents, and asphalt, bitumen, tar, and food products such as corn syrup, chocolate, and peanut butter, and paint, ink, pigments, soaps, and substance. Many products this pump is used to handle. Thank you.